Hello all. Welcome to my presentation on assistive kitchen device to aid the visually impaired in meal preparation with a specific focus on roasting. I'm Avyay. Let's get started. We all know that preparing a meal is a basic activity needed for survival. It involves a range of sensory organs to work with each other for a desirable outcome. Many decisions taken when preparing a meal are dependent on sight. Ability of an individual to prepare a meal can affect the quality of their life. Researchers indicated lowered nutrition levels among those with vision impairments due to their lowered ability to shop for and prepare meals independently. The body of research dealing with assistive devices directly related to cooking is slim, with most products considering ergonomic needs but not focusing on the state of the food being prepared. Whatever little products that exist have been primarily developed for Western cooking and are not suitable for or affordable by Indian households. While there is some research about the vision impaired directly dealing with preparing meals, the learnings do not translate to the Indian context. There are many solutions that cater to enabling navigation and independence while shopping, but these are inexpensive and require a massive overhaul of infrastructure. There also exists some products that have been developed for the kitchen-based tasks, but do not involve techniques dealing with application of heat. Given this, an extensive primary research was needed and conducted. Two rounds of interviews were conducted. Both the interviews followed a semi structured approach that allowed for a conversation to flow while also developing a rapport with the participant. The first set of interviews were conducted with seven participants. This was done primarily to gain an understanding of the space to try and wheedle out problems from non problems. It became clear that the tasks that involve application of heat are challenging for VIPs to perform without assistance. A second set of interviews specifically focusing on four commonly used techniques that involve application of heat to prepare dishes was conducted with five participants. The techniques identified were boiling, simmering, roasting, and frying. A SWOT analysis of the same was done to arrive at a specific focus area. A necessity versus hesitancy graph was made. This summarizes the weaknesses and opportunities of the SWOT analysis. On the x-axis is the necessity of an intervention to aid in the cooking technique, and on the y-axis is the hesitancy of the VIP to perform the particular technique. While boiling and simmering are fairly comparable, with VIPs finding it more approachable to prepare dishes using these techniques, frying and roasting are much less approachable. While there is a great necessity of an intervention in both these techniques, roasting being a technique that VIPs are more willing to try, combined with the fact that many staples are made using this technique, made it the technique I chose to design an intervention for. Roasting is the process of cooking food with dry heat. This usually is done using a small amount of oil to prevent the food from sticking to the pan. Dishes prepared using roasting are dosas, rotis, and many processed meats. The process of roasting a food is as follows: heating the pan, placing the food to be roasted on the pan, waiting for it to cook, picking the food up with a spatula, flipping it back onto the pan, letting it cook on the other side, and finally lifting it off the pan onto a serving plate. But there are many problems faced by the visually impaired when doing this, such as where is the center of the pan? Is the food done cooking? Is the food on the spatula? Has it folded onto itself? How do I reorient myself to the pan if I lose orientation? And many more. Some of the strategies used to mitigate these problems are using the handle of the pan or other elements in the environment to orient themselves to the pan, using the smells and textures of the food to understand if it is cooked, using additional utensils such as a ladle or a rolling pin to grip the food to pick it up, and maintaining a discernible order when preparing multiple foods. But these strategies do not mitigate all problems. There still remains no definitive indication about the center of the pan, something visually impaired users just get used to when doing the activity. Balancing the food on the spatula to pick it up and flip it back onto the pan is a highly visual task which is extremely difficult for blind users to do. And cooking multiple foods using the process above adds more complications into the system. Hence, the design objectives defined were to develop a product that can provide users with a definitive reference to the pan, developing a device that will aid cooking food from both sides, ensuring the above two objectives can be done seamlessly with multiple foods on the pan, all while ensuring the user gets the appropriate feedback with the highest standards of safety being maintained. The problems to tackle were defined as follows: locating the center of the pan, picking up the food and flipping it back onto the pan, and roasting multiple foods at the same time, which involves doing the previous two steps multiple times, all while keeping track of how the foods are interacting with each other. The initial phase of ideation looked at solutions to the problems discreetly, such as providing a reference to the pan through ultrasonic sensors, enlarging the surface with which to pick up the foods, or to create physical partitions to cook multiple foods. But these were not the best ideas to integrate into one holistic solution. The question, why do we do what we do while roasting, was asked to understand if the problems we were focusing on were the right ones. Food needs to be placed on the pan, and for VIPs, having a trackable point is all the more important. But using the handle as a reference only provides an indirect reference to the pan, making the still a legitimate problem. Flipping the food back onto the pan is done to cook the food on both sides, but this is extremely site dependent, requiring high amount of hand-eye coordination combined with a feeling for the balance of the object being held. Roasting multiple foods at the same time is done to save time and reduce the amount of time spent in front of a flame. But keeping track of multiple foods and their state is cognitively demanding. Also, individually picking up the foods and placing it back onto the pan increases the risk of disturbing the order and losing orientation of the foods on the pan. Thus, relooking at the problems made it clear that while locating the center of the pan is a legitimate problem, picking and flipping the food back onto the pan is done as it is convenient for sighted users to do so. A change in process of roasting for the blind users would make it more accessible. Hence, the problem was redefined as how to provide heat from both sides. This approach also solves the problem of having to keep track of multiple foods by treating multiple foods as a single entity. In the second round of ideations, mechanical solutions were thought of for placing food on the center, but this took away autonomy from the users for doing as they wished with the real estate on the pan. Varied solutions such as a toaster for roasting, a hot plate based lid cooktop, and a folding handle were thought of for applying heat from both sides. The ideas taken forward to design the final concept were based on the self-defined constraints of maintaining user safety, ensuring ease of use, establishing familiarity to objects used in the kitchen space, and keeping costs in check. The chosen ideas were the lid with the hot plate for the safe net it provides to users while maintaining familiarity to daily objects. Mechanical solutions for accessing the center were ditched in favor of the ultrasonic sensors as it allowed for greater autonomy of the user while being comparatively less cumbersome. A proof of concept of the hot plate was made using a thermoelectric generator. Vibrational feedback was provided via a DC motor, and heat was controlled using a sliding potentiometer. Ultrasonic sensors were built onto a rig made of Lego to gauge the distance from the center of the pan. There were some limitations such as the Peltier module not being powered enough to reach its maximum heating capacity, not having a good enough heat sink in the steel plate to dissipate heat, being unable to provide intensity varied vibrations through the DC vibration motor, and lastly, not configuring the ultrasonic sensors for different activities done while placing the food on the pan. A scale model of the device was built to check for obtrusiveness when placed with other vessels on the stub. A possible limitation of the physical form of the device noted was its inability to access the device from the side the handle is located. I will now present to you the final design. This is the arc lid, the lid for assisted roasting in kitchens. It is designed to work with a standard 28 cm diameter pan. The lid weighs around 500 grams as compared to the pan's 750 grams. The pan has two modes which we shall now see. The first is locate mode, which is activated when the lid is opened through the swiveling hinge. The hand is placed on the side of the handle away from the heat. As you can see, the lid opens enough to allow access to the pan surface to place the foods to be roasted. In locate mode, ultrasonic sensors provide information about the location of the center of the lid's handle through haptic feedback. Continuous vibrations with varied intensity will indicate when an object is at the center. Once the food is placed, the lid is closed through the swiveling hinge. The lid now enters cook mode. The hand is placed perfectly to access all the elements of the control console. To begin heating from the top, the down button with braille inscriptions is pressed. Vibrational feedback for the same is provided at the handle. This also brings the hot plate down to come in contact with the food. Heat is modulated through the slider. Vibrational feedback is provided at the handle by varying its intensity. Thermoelectric generators heat the hot plate depending on the user chosen heat level. When the temperature reaches 75 degrees Celsius, the haptic feedback at the handle indicates that the food might be done cooking. The lid is then opened and the food is taken out. And this process is repeated again for the next food item. This is how the arc lid will help the visually impaired in roasting the food of their choice. There are many limitations to this design. Material and form were not explored and tested in depth to confirm what aspects of these would work on a product. From the limited time I was able to spend with thermoelectric generators, I believe using 4 of them would be enough to heat the hot plate, but this cannot be confirmed without rigorous testing. Not being able to test a working prototype also makes it difficult to claim anything about the product's real-world efficacy. There are many opportunities for design given how little has been done for assistive technologies in this area. The solution you have seen is just one of a myriad of directions this project could have taken. My relative inexperience with materials and form made me shy away from exploring the space more, but the entire feel and usability of the product can be redefined by focusing on these elements. Also, given the design of the arc lid, it is possible for the lid to benefit multiple users, such as the elderly as well as those with arm injuries. In conclusion, I would like to thank my guide, Professor Swatipal, for her guidance and valuable feedback that helped shape this project, the participants at NAB Worli and NAB Railroad for giving me their time and answering my questions, all the faculty from IXD for their valuable feedback and inputs throughout the duration of this project, Karthik and Kiran for helping me build the prototype, my batchmates for always being there to answer my silly doubts, and lastly, my parents for constantly supporting me throughout the duration of this course. Thank you. I look forward to hearing your valuable feedback and suggestions.